Despite the best efforts of the crew and the paramedics, the engineer was declared dead at 12:40. Hey guys, welcome back to the channel and welcome back to the vlog. If you're new to the channel, a big warm welcome. My name is Tristan Mortlock and this is Captain's Vlog. In today's videos, we're going to be talking about the unfortunate events that happened on board the motor yacht One More Toy in January 2020, where a crew member, the chief engineer, lost his life due to electric shock caused by the yacht. The reason we're talking about this event almost a year later is because the vessel was registered under Cayman flag and they've only recently launched the accident investigation report, which is issued by the Maritime Authority of the Cayman Islands. Now, if you are interested in reading this report, I'll put a link in the description so you can read it and study it further if you are interested. So I'm going to give a little bit of a breakdown of the yacht and the events leading up to the cause of death on board Motor Yacht One More Toy. Right, so here's information about the vessel. So the yacht One More Toy is a large motor yacht with a glass reinforced plastic, otherwise known as GRP construction. The yacht was built by Christensen Shipyard in Vancouver, Washington, in the United States. Construction began in 1996 and the yacht was delivered in 2001. At the time of the accident, the yacht was registered in the Cayman Islands as a commercial vessel and fully certified under Red Ensign Group Large Yacht Code. If you don't know what the Red Ensign Group Large Yacht Code is, it's basically written out by the flag state of the requirements for commercial yachts. If you are interested in knowing more or reading the Large Yacht Code, I'll put a link in the description. I'll be very surprised if anybody clicks on the link, but in that code, it basically stipulates exactly what the vessel needs to have in order to be registered as a commercial yacht. The yacht's electrical generation and earthing system. Now, they're obviously going into this because the engineer lost his life due to electric shock. One More Toy generates three-phase electricity at 480 volts and 60 hertz. This allows electricity to be distributed at either three-phase 480 volts or single-phase 277 volts AC. Other voltages are supplied on board the yacht via step-down transformers. The yacht utilizes a combined earth and neutral distribution where the neutral from the generators is connected to the earth bus bar in the switchboard. From the switchboard, this earth neutral is connected to an earth ground plate fixed to the exterior of the hull. Now, if you don't understand what I'm saying, don't worry. We have a special guest coming on who's going to explain all this in layman's terms. Even I understand a little bit of it, but I'm not an engineer. I'm certainly not an electrician. As the hull of the yacht is constructed from non-electrically conductive material, GRP, the exposed conductive parts of equipment are physically bonded to switchboard earth. There is no direct path for any fault current to return to the earth /neutral in the switchboard or the hull earth plate via the yacht's hull. So what we're going to do now, we're going to hand over to our guest, eSysman, who is an engineer, and he is going to explain what all this means. So eSysman, thank you so much for joining us. This is your first appearance on the Super Yacht Captain YouTube channel. So I'll hand it over to you. Please kindly explain what all that means here on page 4.
Okay, thanks Tristan. Okay, so first of all we need to understand how electricity works. So, as an example, we take this copper wire. I know it's not copper, it's actually solder, but for the example, it's copper. We twist it into two coils and we place those coils opposite each other. And then we connect the ends to make a complete circuit. Now, we place a magnet in the middle and we start to rotate that magnet. The magnet disturbs something in the copper known as free electrons. As the magnet spins, the electrons in the copper wire, they get pushed faster and faster. The electrons are pushed until they reach the top of that magnetic field. Then the electrons start to fall back down towards neutral, towards zero, right? So that's where they began, at zero. Then the magnetic field starts to push them in the other direction, in the negative. And the same thing happens, they get pushed to the maximum of that magnetic field, and then they start to come back to zero. This is known as a cycle of electricity. And this is why it's known as an alternating current, because it alternates between positive and negative, always returning to zero. So this is known as a single phase electric current. Now, if we take a light bulb and connect it to that circuit, as the power increases in the cycle, the light bulb will get brighter and brighter and brighter. Then the electric current will start to fall back to zero, and the light bulb will start to dim. And when it gets to zero, the light bulb will be off completely. Then it goes into the negative and starts to go through that part of the cycle, the negative part of the cycle. And the same thing will happen. The bulb comes back on, gets brighter and brighter, and then starts to dim until it gets back to zero. Now, this is why if you use a camera and you film a light bulb, you will see a flicker in the light bulb. Now that's to do with the way cameras work. I'm not going to get into that today. But that flicker that you see with your camera is what is actually happening. Our eyes can't see it. The reason why our eyes can't see it is because this happens so many times every second that it's invisible to the naked eye. We measure this by something called hertz. So 50 hertz or 60 hertz if you're in the US, that's the amount of times this cycle happens per second. And that's why we can't see it. So remember, the current always returns to neutral. The problem with using single phase electricity on a vessel is that this light bulb that's going on and off, if you try to run an electric motor on that same power, you're going to have that same thing is going to happen, right? Three-phase electricity is three single-phase electricity, if you like. So the electric circuit of a single phase, as we've just talked about, then we add a second one. We rotate it 120 degrees, and then we take a third one and we rotate it again at 120 degrees. As the first phase gets to its maximum, the second phase is at zero. As the first phase starts to drop back down to zero, the second phase is reaching the maximum of that magnetic field, and so on and so forth. So each one of them is rising and falling at different times. And the reason why we do this is so it increases the actual power of that motor. The motor can spin faster on three-phase. So the three-phase electricity is used for things like elevators, HVAC or air conditioning systems, electric motors, things like that. And single-phase is what you would have in a domestic house, and what you would on a yacht you would use, like TVs and lamps and computers and things like that. They're on single phase because they don't need so much power. Okay, so going back to our circuit, the circuit consists of two parts: the conductor, the copper wire, and the insulation. And the insulation keeps the current inside the circuit. The easiest way to explain this is a power cable. So we have a power cable here. So inside here, we've got the copper wire that runs along, and on the outside, we've got this rubber on the outside, and that's our insulation, and that stops us from touching the current. If you remove that insulation and the cable comes in contact with something that's magnetic, like the casing of an electric motor, for instance, that electric motor casing now becomes live. So for this reason, the casing is earthed. So a cable is connected to the outer casing and that is run to earth, run to ground or neutral. Remember, the electric always goes back to neutral. So what we do is we take a cable, we connect it to the outer casing, and then we run that cable to neutral or to ground. And that way, if someone touches that casing and the insulation has failed, they won't be electrocuted. However, this vessel has a GRP hull, which is not electrically conductive. So the earth in the equipment was bonded to the bus bar in the switchboard. A bus bar is essentially a strip of electrically conductive copper. And also on this vessel, the neutral part of that circuit is connected to the same bus bar. And that's the combined earth neutral distribution. The bus bar is then connected to a grounding plate that's bonded to the exterior of the vessel's hull. So what can cause the insulation to fail? So excessive heat. So maybe an electric motor is overheating constantly and it can actually cause the insulation to dry and crack and fail. Mechanical vibrations can also cause it to fail over time. Mechanical damage, maybe an impact. And water ingress is another thing. Remember, water is electrically conductive.
I've always wanted to read more books, but it can be tough to find time to read hundreds of pages with so many distractions around us. This is why I'm excited to share our sponsor of today's video, Blinkist. Blinkist is the only app that condenses non-fiction books to give you the key insights and knowledge found in each book, so you can apply those lessons right away. Blinkist offers thousands of options to choose from, and each book is about 15 minutes to either read or listen to. Blinkist has allowed me to read the key insights into some famous books such as Beyond Victory with Nico Rosberg and Leadership is Half the Story with Mark and Samantha Hurwitz. Without Blinkist, I honestly would have left these books unfinished, which is why I highly recommend downloading Blinkist today using my custom URL found in the description. With the audio option, I've been able to start my day by listening to a new book, which I found to help set up my day for success. I honestly think this is one of the best apps out there and offers so much value for anyone looking to learn. Best of all, the first 100 people to go to blinkist.com/SYC will get unlimited access for 1 week to try it out. You'll also get 25% off if you want the full membership. And for those of you who aren't as quick, don't worry. You also receive a 7-day trial completely free, and you can cancel at any time during that period. You've got nothing to lose and a lot to gain. So head over to Blinkist using my link to try it out today. Right, thank you for that explanation, eSysman. Don't go anywhere because he will be back to explain further as we go through this report. One More Toy was described by the captain as a very busy charter yacht leading up to the accident. The yacht had a crew of 9, comprising of a master, the chief officer, the engineer, a bosun, deckhand, chef, the chief stewardesses, and 2 junior stewardesses. Towards the end of November 2019, the yacht's regular engineer left to go on vacation, and a relief engineer was hired to serve on board the yacht while the regular engineer was on leave. At this time, the yacht was undergoing a period of maintenance at the Sea Haven super-yacht marina in Fort Lauderdale, Florida, USA. The engineer was expected to serve on board the yacht for approximately 2 months. On leaving Fort Lauderdale, the yacht proceeded to the Caribbean, where a number of cruises were undertaken with guests on board. During his time on the yacht, the engineer was described as conscientious, competent, and hardworking by all the crew on board. In addition to the routine engineering tasks required to keep the yacht operating, the engineer also spent time attending to various maintenance and repair tasks that were scheduled for the yacht's next shipyard repair period. The engineer was also engaged in expanding the use of the yacht's planned maintenance system, otherwise known as PMS, to manage more of the maintenance and repair tasks required on board. During his time on board, the engineer had periodically been working on the generator's load bank that had been out of service for an extended period of time. We're going to explain what a load bank is later on, so do stay tuned. On the morning of the accident, the yacht was alongside in St. Bart's with a party of 7 guests on board. The party of guests comprised of the owner, his family, and friends of the owner as well. No guest activities had been planned for that morning, and the master described such owner trips generally slow and routine when compared to when a party of charter guests was on board. On the day of the accident, the workday on board One More Toy started when the boatswain came on duty at 6:30 a.m. to open the boat. For a normal day's activities with guests embarked, the boatswain met with the engineer in the crew mess, and after coffee together, they both went about their work day. The boatswain was working on deck and the engineer in the engine room. The engineer was working on the load bank that had recently been returned to service 3 days previously. The load bank was located below the floor plates of the engine room, close to the division with the engine room and the engine control room. At around 10:30 a.m., the engineer called the boatswain on the radio and asked for the boatswains to assist him in the engine room. This was common when the engineer needed an extra pair of hands with the task he was working on. The boatswain joined the engineer in the engine room and assisted him in the routing of a new flexible seawater hose connected to the generator load bank. After assisting the engineer with the routine of the flexible hose, the boatswain returned to his other duties on deck. At approximately 11:45 a.m., the boatswain noticed that the yacht's underwater lights had been left on from the previous evening. The switch for these lights was located in the engine control room, and the boatswain went there to switch off the lights. On entering the engine control room from deck, the boatswain noticed the engineer was lying on the floor plates, still working on the low bank located below the floor plates. The engineer was lying across the door, still between the engine room and the engine control room, with his legs and lower body in the engine control room. When the boatswain called to the engineer, he received no acknowledgement. The boatswain then approached the engineer and found the engineer to be unresponsive. The engineer was described as extremely pale, with visible injuries to his head, which the boatswain attributed to the engineer's head making contact with the load bank or the surrounding structure. When the engineer remained unresponsive to verbal and physical stimuli, the boatswain raised the alarm on board the yacht. While the boatswain was checking the unconscious engineer for life signs, help arrived from other crew members, while the master and 2 crew members administered first aid response to the engineer. A third-party crew member raised the alarm ashore to the harbour office located about 20 to 30 meters from the yacht. Those attending the engineer could not discern a pulse, and the engineer was not breathing. A stretcher, neck brace, and automatic external defibrillator, AED, were brought to the engine control room. With the engineer in a neck brace, he was placed on the stretcher and CPR was started. The AED was attached and indicated no shock. Suspecting that the engineer may have received an electric shock, the master also disconnected the yacht's running generator from the switchboard, thereby cutting electrical power from the yacht's switchboard. So technically, he could have saved other crew members' lives from doing that if they were to touch the same place where the engineer was working. Maybe. An ambulance quickly arrived at the yacht, and the paramedics took over the efforts to resuscitate the engineer. An AED from the ambulance was attached, and this also indicated no shock. CPR was continued for a further 20 minutes. Despite the best efforts of the crew and the paramedics, the engineer was declared dead at 12:40. One More Toy is a 462 gross ton yacht and has a propulsive power of 2,686 kilowatts, and so the engineer was qualified to serve as chief engineer on board this particular yacht. Since 2006, the engineer served on over 20 yachts as both the full-time engineer and was employed on board Motor Yacht One More Toy under a fixed-term Seafarers Employment Agreement, otherwise known as SEA, running from the 22nd of November 2019 until the 1st of February 2020. Upon leaving this yacht, the engineer had arranged his next employment to start in mid-February 2020 as the engineer on a delivery voyage from Uruguay to Palma. As noted previously, the engineer was described as conscientious, competent, and hardworking by all on board. He was in good general health, having undergone his previous seafarer medical examination on the 8th of November 2019, prior to joining the yacht. During this examination, he was determined to fit for work without limitations or restrictions to his fitness. So we're going to head over to eSysman now, and he's going to explain pretty much what happened and how got electrocuted. He's going to explain what the load bank is, and then also going to explain the investigation of the findings of the cause of death and also the electrical findings. So eSysman, back over to you.
So this yacht, like most yachts, gets its power from diesel generators. Now, a diesel generator is designed to run at between 60 and 75% of its maximum load. The load is what equipment is taking power from that circuit, so electric motors, televisions, air conditioning, etc. Running a generator at a very low load, like under 30% of its maximum load, can cause running issues, and also it can cause high hydrocarbon emissions. So to prevent this from happening, a load bank can be used to put a load on the generator. Now, what is a load bank? A domestic thing that is comparative to a load bank would be an electric kettle or a hairdryer. And the one on this vessel is like a giant kettle. It has 3 industrial immersion heaters inside of a metal casing, and they flow seawater through it, and these heater elements heat up the seawater that's flowing through it. This load bank operates on 3-phase 480 volt power. If we want to test the earth is working on a device, we will use a multimeter and we'll run a small amount of voltage through that cable. We'll measure at one end to the other, and we should get the voltage goes from one, just like an electrical circuit, the voltage should go very easily and complete that circuit. The multimeter will show a very low resistance. On a multimeter, that will be displayed as something like 0.4. Anything under 0.5, and that's very low resistance. In the report, they said that prior to energizing the load bank, turning on the power, they measured the resistance between the load bank earth and the true earth, and it was measured at 105,000 ohms. Now, in our test with our good circuit, only requires 0.5 ohms. This was 100,000 ohms, very high resistance. So there was obviously an issue with the earth cable. Maybe it was frayed, or it was partially broken, and there was a very high resistance. If the earthing cable was completely broken, you would just get an incomplete circuit, because there's no way for it to get from point A to point B. Very high resistance means there's something there, but it's very poor. It also says when they energized one of the load bank elements, so there's 3 elements in this unit, so you can turn them on independently, one at a time. He said when they turned on one of the load bank elements, an electrical arc was observed between the load bank earth connection termination and the casing of the load bank. So it says the continuity recorded a resistance in excess of 100,000 ohms. This is after the arcing. So the investigators, this is going back to the report, the investigators used a digital megameter to run a 500 volt DC insulation resistance test. So basically they put 500 volts DC from a megameter through the heating element to test the insulation. And what they found is on each element, the insulation had failed. So we go back to our cable. So the outside, the thing that protects you from the current that's flowing through the copper wire inside, this had failed on all three elements. Because the earth had that massive resistance, remember? The 105,000 ohms resistance. The earth wasn't functioning. So the job of that earth was to take that live current and the earth was designed to take it from the metal casing and send it back to the bus bar safely so nobody gets shocked. But the earth had failed, or it was failing. So because the insulation had failed on the elements, it was transferring it into the metal case. The investigators found evidence of water ingress where the electrical cables were inside the canister. It says that it is probable that the lack of effective earth bonding for the load bank casing resulted in the engineer suffering electrocution by providing a current path between the heating elements and the true earth through his body. This path would have been completed via an earthed component in the vicinity of the load bank. So the electricity is coming through into the giant kettle. The electrical cables on the heating element have lost their insulation. The earth strap or the earth cable that runs back to the bus bar for the outer casing has failed or is failing. The electricity goes into the outer casing. It's alive. The whole casing is live. The unit is still running. The engineer is either standing or laying near this unit. Perhaps he's laying down on the floor, looking underneath, checking for leaks. Now, his feet are sticking out. Maybe he's touching another piece of equipment that is properly earthed. Or maybe it's just the decking, the metal decking that you often find in an engine room. He touches the casing, maybe with his hand or with his head. There was talk of a head injury noticed. The electricity goes through him, because we are electrical conductors, and it passes through, returning to neutral. Remember, it's always returning to neutral. And it's going through him to reach the earth of whatever he's touching, either the floor or another unit. And that is most likely how he died.
That was eSysman. Thank you so much for giving us that explanation. So finally, guys, the way ahead, how we move forward from this. The final part of the investigation will focus on existing electrical safety requirements for yachts with an emphasis on GRP vessels, glass reinforced plastics. The investigation will also look at what changes to these requirements, if any, would prevent a similar accident occurring in the future. Finally, a big thank you to eSysman for taking part in this video. If you don't know eSysman, I put a link to his channel in the description below. Actually, I put a link to both his channel. He has 2 channels. Go and watch his content. One of his channels is based on yachting and one is based on tech. So thanks again to eSysman. Thank you all so much for watching. I look forward to seeing you all next time. See you and ciao.